computation operator and stuff like that. That's it. But they can't do anything hardwired to any of the systems in the plant and stuff like that. So again, it's overkill. But we know that realistically, because we're seeing all of our competitors, even with other European parent companies, do the same thing. They're dropping their, like, hey, we can't keep limiting ourselves in this massive tool chest that's available.
Yes.
All because a few people are worried about secrets getting out. Like there's no trade secrets. Anybody's going to steal from the abrasives industry utilizing AI. That's a lot of investment for something you can find out by applying for a job, and within 2 weeks you know what the recipe is. You know?
I like how you opened it. I think there's a lot to unpack there, but you mentioned something about a lot of opportunities there to use the tools. There's a lot of different applications, and that's something that we're going to cover today. Is there any other interest areas that you all have for AI other than AI projects being started in organizations? That's one thing that we're going to cover. Any other interest areas that you have?
We're in the College of Business. We're trying to figure out how we're going to teach our students to use AI without letting them use it to do their homework.
Oh wow! So the students are good.
We want to teach them to use it, but we don't want them to use it.
It's an interesting dichotomy, right? What else? Do you use AI in your daily lives in any capacity? What do you guys use it for?
Like checking homeworks, like explaining some stuff.
Also, they're trying to get you to use it, so I'm interested to hear how you're using it. How do you use it in your homework?
Like showing me first steps, and then I can like apply or like explain me something in more detail, so I can understand it better, and then like apply it to the problem and solve it.
Yeah, I think that's the best thing that I use it for, is how much it can dumb it down for you, for any sort of work, whether it's very complex or even just, hey, I've never learned this, or I never saw that in class.
Yeah, that's awesome. There's a lot of learning applications, organizational capacities. Any others that we'd like to just go over? All right.
I've seen it attempt to be applied in a lot of different processes, not with great success, to be honest.
Could you tell me a little bit about that?
I've seen it for optical inspection, not working great. A lot of the times, end up having to have a human do a second set of eyes on it anyway.
So the AI does the first round, human needs to audit it.
Yeah, and then of course it started as like, oh, we'll just be doing that for a couple months, maybe.
And what industry do you work for?
Aerospace.
Aerospace. You guys can come in, we're just getting started. Okay.
I didn't want to walk in front of the camera, I'm sorry.
All right. So here's some of the high-level points that we'll be discussing today. First, we're going to have a discussion, high level, on what is artificial intelligence, where it's headed, how do you guys currently use it. Then we're going to talk about launching AI projects. So the session is going to be focused on the CAPM AI, which is the PMI's industry standard for leading AI projects. We're going to learn that framework. Coming back to your point, you said that you're going to launch some AI projects internally in your organization. So we're going to go through a framework that is industry best practice for launching AI projects from ideation all the way to implementation. So we're going to learn how to pilot those. And we're really going to focus it to process first philosophy, and we're going to tie it to process maturity models in our organizations. Just because AI tools are out there doesn't mean that our organizations are going to be ready to implement them successfully. So we're going to talk a little bit about that. And then, like I said, we're going to talk about the framework of CPM AI from Project Management Institute, and what is the path to AI readiness going to look like for the organizations that you're part of, or if you're students, how are some steps that you can take right now to prepare yourselves, because this is a rapidly evolving field, as we know. So that's just an overview. I would like to introduce myself. My name is Seb Gashti for short. And I'm a process optimization consultant at Illuminative Strategies. Does anyone know what a process optimization consultant does?
Take a guess.
Yeah, absolutely. Yes, sir. Absolutely.
I presume you probably take a look at a specific action or within a process.
Yeah.
And then you kind of give advice about areas of improvement or just narrowing things down.
Yeah, you're spot on. We look at operations, we look at a process, and how are things done on a day-to-day basis. A lot of leaders usually have a perception of how things are done from a high level, but what we see a lot of times is they have a disconnect with the people that actually do the work. and it makes it very difficult to find opportunities to improve an organization, because we're looking at it from 1,000 feet, and sometimes it's very difficult to zoom in. So that's what we help a lot of industry leaders, and we focus a lot on public sector, so a lot of government operations, which we all know can really be optimized sometimes, right? So that's a little bit about what I do. I'm a project management professional, and I'm also a Lean Six Sigma Black Belt. So to start our session, very high level, what is intelligence? That in regards to artificial intelligence, we're talking about intelligence from a human capacity. What does it mean to be intelligent?
To know things ahead or to know everything that you can possibly know, or more than that.
Yeah. Is it like predicting the future?
Not necessarily, it's something, you know about something beforehand, or you know about almost everything that you could probably know about.
Yeah. Knowing about wisdom, perhaps, right? Yeah. Knowing things.
Knowing things.
Absolutely. What else?
Is the ability to do something smartly,
Ability to do something smartly. What is smartly in this context?
improving efficiency, daily
Efficiency. Doing things better than we usually did before. So iterative improvements. Okay. Absolutely. What else?
Maybe the ability to apply lessons learned to some new process or
Yeah.
something new.
Absolutely. What else? When we think of infants, for example, you know, they're growing up, and we see their intelligence grow over the years. What does that remind you of?
I look up for the word competent. and
Competence, okay. What does competence mean in this case?
Capability.
Capability. To do tasks, right? Absolutely. Any others?
From a behavioral standpoint, the ability to not only take in and assimilate data, but then eventually extrapolate and interpolate that data.
I like
So,
that.
so you can conceptualize something outside of the observed data set.
Yeah, that's close to one of the standard definitions. Standard definition is the ability to perceive context, like you said, taking in input, and then recognize patterns of what's happening, and then solve novel problems, right? You're competent to solve these problems, but most importantly, being able to adapt to change. As humans, there's a lot of change that's coming our way, and we need to be able to continuously adapt and evolve. So that is a very big component of intelligence. So AI engineers have been dying for, I would say, centuries. This has been in sci-fi and beyond, to create machines that think like humans and can perhaps surpass human beings. And this is what we call artificial intelligence, right? So we just defined intelligence as a whole, but what is artificial intelligence? What does it mean to you all?
It's not something, the system is learning from what we give. It's
Mhm.
not learning naturally, initially at least.
Yeah.
So unlike us, we learn it from the experiences and things we do and see. But for a system, we are just feeding the information and asking it to learn from it and then those
So
data.
it's learning from us.
Yep.
We learn and then we feed back
Yeah,
what
it's-
we've learned to the
It's
AI.
more about replicating our intelligence.
Yeah,
more
I
efficient
like
way.
that. What else? Any other ways? There's no wrong answers. Let's take a look at what AI could be defined as. And it is very wide, right? It's rapidly changing, so we can try our best to define it, but it is very subjective too. The quest to teach machines, not to just compute, but to comprehend. So it's very similar to what intelligence is. Now we're teaching it to machines. Previously, machines were very good at following set instructions. You would give it a code. And the codes have evolved so drastically, all the way from HTML to Python, SQL. There's a lot of different coding programs, and machines were very rigid to following those very robotically. With artificial intelligence, the goal is to teach these systems to learn, predict, optimize without any human explicit instructions. So that is the goal that we're striving towards. And that is what we call going from automation to cognition, getting very close to what humans do and think in regards to how we define intelligence, teaching it to machines so that they can do it too. And so the core aspects of AI, like we just defined, can really be summarized into 3 parts. So machines, to be able to think like us, they need to be able to have perception. And what we call perception is really to have sensing and understanding of inputs. Humans have 5 senses. right? We can touch, smell, apart from, what are some other senses that you can think of?
Vision,
Vision, what else? Taste,
smell,
smell, touch it, and what's the fifth?
Balance,
Hear.
pressure.
Yes, we can hear, absolutely. Once we take those sensory inputs in, we need to be able to make predictions, right? I hear that my friend is calling me, I predict that he wants to get my attention, I look over. So that's understanding possibilities and thinking ahead, based on the input that we receive. And number 3 is planning, adapting and self-learning. If I hear my name enough times, if somebody says Sep, Sep, I will remember, and I will plan to turn my head and say, okay, they're trying to get my attention. So we're teaching machines to be able to think like us in these core 3 steps. And that's how machines do a lot of their thinking. Now, the utopian dream of AI engineers has been in the working for centuries. Very recently, it has really exploded in a lot of progress. And this really came into public consciousness with some of the examples we heard here about conversational AIs, right? With ChatGPT. Anyone here use Claude, ChatGPT? What are some of your favorites? You want to shout them out?
Claude recently.
Claude, okay. What else? Claude is the winner. Do you like ChatGPT as much?
I used to like it earlier, but with the recent Cloud updates and new model, I think I'm using Cloud more than ChatGPT.
Yeah. How about Gemini?
It's good at problem solving.
Copilot? So it's also very interesting how these companies are now competing to take the top spot. We've got Claude as the winner right now. It used to be ChatGPT, and they're constantly evolving, trying to one-up each other. It's really an AI race, right, to see who makes it to the top. But the utopian dream of AI engineers was to create an ultimate polymath, is to make a machine that is equal or surpasses human intellect across economics, creative and scientific endeavors. So that is the goal that we're going towards. There's a famous picture that was going around on social media, memes and other things. This is the world if this was true. So AIs are really trying to create a world that could be utopic. Will we get there? It's hard to tell. But what we can expect to hear from the mission statements and vision statements of Anthropic, OpenAI, and other companies that are developing these models is they believe in an era of abundance, unleashing something called superintelligence, machines that can solve humanity's grandest challenges, curing disease, ending resource scarcity, and creating a post-scarcity future. What does that look like for you all? Does that look like a good future? Maybe, right? So the pursuit of artificial general intelligence is something that was developed on OpenAI's website in 2023. And this was written by the CEO at the time, Sam Altman, and it was called Planning for AGI and Beyond. It's very similar to what we just went over. Their mission statement is, we want AGI, artificial general intelligence, which is kind of at the top peak of what AI could be in the future, to maximally flourish the universe. We don't expect the future to be unqualified utopia, but we want to maximize the good and minimize the bad for AGI to be an amplifier of humanity. So very grand, big, bold vision, which is really cool, right? It's what could be possible. And we want the benefits of access and governance of AGI to be widely and fairly shared, and they recognize that there is a lot of massive risks to the future of this technology. So that is very important for us to navigate carefully. So as quality professionals, as students going into the world, we need to be very aware of the risks, but also understand that there is massive upside to the way that quality, reliability, and other functions of businesses can be planned. And so there is 5 stages to this roadmap, and this was published in a paper in 2024. This paper was published in 2024, and it was called The Path to Superintelligence, a critical analysis of OpenAI's 5 levels of AI progression. So this is OpenAI's model for the next couple of decades. What they set out to do first was create chatbots. These were some of the models that we were talking about using, right? So we have language understanding, language generation, it's conversational AIs. Then we graduated to reasoners. Has anyone used AI recently where we see these models have evolved to think in sequential steps? What are your thoughts on that? Do you like the experience before or now?
No, because you can see like how it thinks and like then you can improve it.
Yeah.
Like if he's doing, and you can find possible mistake in that step, like where he's doing a mistake and he's getting the result you want to get.
Absolutely. And so it's able to take our big conversations, break it down by itself, and prompt engineering, which was how we talk to machines, is becoming even less relevant. It used to be a big skill, right? Now it's becoming even less relevant. Number 3 was agents. So decision making and execution, being able to execute tasks based on the prompts that we give it. We are currently somewhere between level 3 and 2, but we're getting very close to number 4. Some claim that number 4 is getting pretty close. Number 4 is AI is becoming innovators. They're coming up with ideas that are not developed before. So this is PhD level reasoners and agents that are able to go out, aggregate huge amounts of data, and come up with new synthesized ideas that were never available before, just like university researchers here. You're an R1 institution at SIU, so if that promise comes true, these innovator models are going to be able to come up with brand new research. So this means space research and any other application. Number 5 is their AGI becomes kind of real, and is organizers. They become so good that they're able to run multifaceted operations in organizations. So they become CEOs. They become capable of running businesses with just a few people. And this is where we can see multi-billion-dollar operations and maybe even crossing trillions of dollars ran by AI agents. You're far from it, but that is the roadmap that they have defined and we're headed towards. Before I move on, what are your thoughts on this 5-level framework, and where do you all think that we are currently on it? Does it scare you? Does it make you hopeful?
The level 5 is definitely scaring, but I think we are somewhere between 3 and 4.
Yeah.
I think we have achieved 3 already with tools like anti-gravity, which can code by themselves and deploy it and everything, but I think we're at 3, close to 4, but level 5 definitely scares.
Yeah. How does that make you feel? Do you like it? Are you excited? Are you scared?
I'm scared, I'm definitely scared with level 5.
Yeah. Any other feelings?
See what happens.
See what happens.
I don't, if something, I think it's up to the people who wield it are really gonna actually dictate its future. I don't think it's going to be inherently, like all things, I don't think it's gonna be inherently good or bad.
Yeah.
But I think the choice that people make and how to implement it and where will dictate how it's perceived and its ultimate effect on us.
I like that definition.
The vague vision statement of maximizing good and minimizing bad isn't really reassuring.
Gotta keep it wide, right? They don't know what's gonna happen. If it destroys everything, oops. Right?
Try again.
Yeah. Comes back to your how you define it, right? You see what happens. The promises, again, in the world of quality, reliability, is if we do it right, AI projects can yield improved accuracy and reliability. They can achieve greater scale of productivity for us, for humans to work better. And this is what we call augmented intelligence, right? It's humans and machines coming together, combining the best of both worlds and achieving great things. Eliminate drudgery and dull tasks. A lot of people are very tired of doing the same old work every day, so machines can eliminate those drudgerous tasks. Enable continuous monitoring on data and other things in our organizations. Extract more value from data as a whole, because they're great aggregators, and provide assistance to those in needs. Very similar to what we covered. Now, in Six Sigma and DMAIC, what are some examples that you can think of? You mentioned a few projects that you're currently working on. Could you share how those projects are taking shape in these areas, perhaps, and which one of these would fall under? Is it?
So one of the big things that we want to utilize AI for is we have over 40,000 SKUs in our company, because we might have one specification that's useful in a certain industry, but based off of our customers' machinery they bought, they have to have various geometries and such. So you might have relevant running chart data on each one of those individual material numbers, but now if we want to calculate, okay, what's the chances of fracture in that family of products? So now we have to have a massive amount of data where we separate it out, then attach a dynamic flow of, okay, yeah, this product has an 80% scrap rate, but it makes up 0.01% of our volume that we produce. So calculating a family's performance versus individual material numbers. So whereas that might take a team of engineers a full-time job, to calculate all that for that many products worldwide. AI, we know that we can, we can build we have a limited amount of exposure to like SAC, Power BI, using SAP. Being able to take all that data that's already in there, instead of me building a clever dashboard, just being able to query, hey, I'm looking at this hierarchy of functions. What are the likelihoods that the product is going to perform at this that I can give the sales team? And so that's what we're going to have, is we're going to give a predictive yield rate to a certain product, because in our product it's basically ceramic.
Does it fall under reliability here? Reliability
Oh,
engineering,
yeah.
Six Sigma,
Yeah,
quality
reliability,
inspection?
yeah.
Any other applications that you observed or think that it would work well in a certain industry?
Inspection.
Inspection? Absolutely. Any examples? How you think it
Like-
would aid inspection?
Sensor for checking like if there are like cracks or something, and if you have like put it far away, or for rework, if it's
Yeah.
like not in the dimension it should be.
Any others? So a couple examples over here. I think you covered very good ones. Being able to interact with the data in a meaningful way is going to allow us to focus really on all these areas. Lean and waste and elimination become a lot more prevalent, and we can actually undertake Kaizen events, and opportunities to improve become easier to identify, and we can launch those and make organizations work better. So according to Project Management Institute's certified, so CPM AI stands for Certified Project Manager in Artificial Intelligence. They've rolled all AIs currently that we have into 7 core patterns. And the patterns mean that these are repeatable shapes AI projects take based on the kind of problem that we're trying to solve. So the first one that we discussed widely and we are very familiar with is conversational models. They communicate with human language. So this is, for example, you can open your phone and have a conversation with ChatGPT or Gemini, show images, and it is able to respond to us in a human way. In quality and lean, we can see that AIs that can answer quality procedures. If you're onboarding someone new, for example, instead of us spending a lot of time, the AI can be trained on all of our information, and so the person can have an interaction to understand what kind of procedures do I need to do for this, and what's the quality. Recognition is the next pattern of AI. Now this interprets unstructured inputs. What we call unstructured data is really images, videos, text, sound, handwriting. Today, it's also embedded into conversational models. So I can take a picture of a whiteboard brainstorming session, feed it to the AI, and it's able to transcribe for me what that is. I can also transcribe my voice. So if I can take this, feed it to the AI, it's able to extract words from speech. Face unlock on the phone, Shazam, does anyone use Shazam to identify songs ever? It's really cool, right? It's able to take a voice and turn it into something that can recognize something. In quality, recognition can aid camera systems detecting surface defects, which is similar to what we heard here. OCR, reading handwritten inspection forms, right? Sometimes a very drudgerous task to receive bad handwriting and try to make what it is. AI can do it, and I think you mentioned human auditing can come in to make sure that that is still good. Anomaly detection learns what normal looks like, so we understand the baseline. This requires us to have good historical data. Once we understand that baseline, we can see if we're moving up and down. And that brings us to statistical process control, which is a very core concept in quality engineering, right? Is how much are we deviating from that baseline? SPC alerts can let us know if we're moving in or out. Predictive analytics is perhaps one of the coolest ones that often loops with hyper-personalization. Do we have any Instagram, TikTok addicts here that cannot get off their phone? We can be honest.
Sometimes.
Sometimes. So the reason behind that is really the hyper-personalization AI as well as predictive analytics. They're getting so good at understanding vast amounts of data about us to predict what we want to see. They understand what kind of content we like, what kind of music we like, what is our personalities, and they're able to continue to give us recommendations, and it's going to be very difficult to get away because it's so hyper-tailored to our tastes and wants. And so in quality and lean, that can be adaptive training paths by employees. AI can understand if an employee is lacking a certain area and can recommend, hey, take these lessons. Or it could say, this dashboard is tailored to this specific role rather than you having to click around. Predictive analytics could be forecasting defect rates. It could be a supply chain. For example, if you have good historical data, it can say there's going to be a massive shortage of rubber gaskets coming in the market. You should plan accordingly. So we can see trends before anyone else is doing that. Goal-driven systems are, it searches for the best solution of their constraints like time, cost, and capacity. And so this includes Google Maps, choosing the fastest route. Does anyone use GPS these days? Right. So it's able to take massive amounts of geographic data, for example, and understand the best routes to get us to the destination. In the world of quality, optimizing production schedules. It's very difficult sometimes to have people working shifts. There's a lot of, by studying time trends, AI can say, you're busiest from 7 to 10. Why don't you bring these people that are doing nothing around this time and put them here so that they can provide the most value to the customers, so that we can deliver better customer service and citizen experience if you're in government. Lastly, autonomous systems act independently of the real world with minimal human input. This is, has anyone heard of the Waymo or the self-driving taxis? What are your thoughts on those?
Well,
Would you sit in one? No, not yet.
right. I rode one in Phoenix.
Was it cool?
Yeah, it's okay.
It's okay.
My son's Tesla was much better.
Even Teslas, right? Teslas now have
Yeah.
the ability to drive themselves.
Although FSD is not the right acronym. Because Tesla calls it full self-driving
Mm-hmm.
supervised.
Supervised, yes.
And that's their legal out.
Yes, that's the legal out. You're not quite there yet, but the systems are getting quite better, right? We've seen the evolution of these models. They're just learning and they're adapting. A Roomba, navigating a room is actually artificial intelligence too. Something I found out. A self-driving car braking on its own. In the world of quality, self-adjusting robotic systems or production rerouting when the line stops. So you don't need the onboard going red anymore, you can reroute productions. Pretty cool. Now, are we excited about the possibilities of the patterns that we saw?
Well, I'm sorry, I
Yeah.
have a question
Yeah.
regarding your second from last slide.
Yeah.
Now, I mentioned DMAIC, you mentioned reliability, we have lean waste and quality inspection. So from my experience using AI, I have questions of its quality of accuracy. As a black belt, you can understand that a lot of the calculations get a little long.
Yep.
When I've tried to cross-reference my work, it is full of errors. And now there's things that it is good for. For example, like you said, like quality and inspection. You got the eyes that can detect defects on a level that we can't. Lean and waste, they can go over the philosophies of it and give you suggestions. But with reliability engineering and Six Sigma, I don't necessarily believe that it's there yet. Maybe it was the source I was using, but what's your opinion on that, the quality of AI for those uses?
I think it's the way that it's deployed, number one, and that's something that we're going to go into. But I think it's really about understanding the limitations of our models too. What is our training data set, right? Because a lot of times we're making references to that baseline. So I think if you have really bad garbage in, garbage out method, it's old saying in data science, right? So if our organizational data is really bad, I think we're going to get really bad outputs. And I think the better we do in data preparation, which is part of the model, I think we're going to get better responses. But also understanding the limitations, understanding that it's going to be bad at times, understanding that it's not 100%. So understanding that, yes, there's going to be a lot of errors, and that's okay, because we need to check it at times. But hopefully over the years, we do better with data, and the more historical data, I think.
Yeah, I believe so too, because it is an adaptive learning tool, so.
But just like Six Sigma, right? Like it's very difficult to achieve 0 defects.
Yeah.
So I think it kind of ties into the philosophy of how do we get it to that Six Sigma reliability standard over the years. And I think in manufacturing, it took us a long time to master. Many, many decades.
I think one thing that is relevant when you're saying, hey, the AI is not accurate, like from a manufacturing standpoint, take the A out of it. What does intelligence do? I can go to the factory floor in my plant in Salem.
Yeah.
I guarantee there are 5 operators that if I grab their wheel after they pull off their machine, they will have written down that it's 12 inches, 12.125 inches thick. And I guarantee you if I go grab a caliper myself, it won't be. So now I have to correct that employee, I either have to train him or discipline him. But it's the same thing with AI. If you do, like we were talking about, when you can see the step-by-step in ChatGPT, how it's thinking, if you see where the thinking error is, just like with a human being, if I say, hey, you can't grab a vernier caliper and measure a non-flat surface, you have to grab a point-to-point caliper.
Yeah.
That's a training thing, with correct, same thing with AI. So if you're saying, hey, it's referencing wrong, correct it. The good thing is AI hopefully remembers it far longer than Frank, who smashed a 12-pack last night. And he's hoping to remember how to use that, how to reset that vernier to 0 and how to tear it, you know.
Yeah, and that's
So-
what I do like about the AI chatbot, because I have, you know, I like to converse with it when I do, kind of like a normal person. I was like, hey, no, that doesn't make sense, check this. And they're like, oh, I'm sorry, and it'll correct. And that's a very interesting thing, you know, and I've caught it making mistakes on, like really simple mistakes. You know, going over homework sometimes, I'm like, let me see what this says. Or, you know, I have group chats with classmates and we all cross-reference, but it's like a higher, like, I won't say higher, but a highly intelligent classmate. That's kind of how I teach it, well, treat it. And, you know, just like us, it makes mistakes.
Yeah. It is a good point you bring up. The limitations are very real.
The other night, I had an issue where Copilot was giving me answers I knew was wrong. So I went to Gemini and asked the same question. Then I put Gemini's answer in Copilot and said, Gemini says this.
You gotta insult it a little.
Copilot did not like it. And basically it came back and basically tried to show itself the models it uses. Basically, I'm superior to Gemini and here's why.
Dang, that's crazy.
Superior to complex. So that is a very good point that you bring up, right? Is how can we be so trusting in these outputs that we're getting? And it comes down to this question, right? It all sounds really cool and exciting. You're promised all these great things. AI sounds pretty cool. I want AI in my organization. Everyone else is doing it, right? We see our competitors doing it. It's awesome. I want it too. So let's get started with an AI project. Sounds good? We go in and we see that, okay, there's definitely risks. What % of AI projects do you think fail to deliver their promised value? I'm a vendor that deploys AI. I come to you and I say, listen, these 7 types of AI I just showed you, they're gonna change your world. They're gonna make you so much money, everything's gonna be heaven. The utopic dream I sell to you. What % of them do you think actually deliver?
C.
C? 80%?
Fail to deliver.
I'm
Fail
not
to deliver.
Fail to
I would
deliver,
say
C.
A,
Oh yeah,
I would think.
definitely C.
So 80% failure rate? How many 80? Okay. How many 65? Okay. How many 20%? 20, okay. So the majority got it right. 80% of AI projects fail according to Project Management Institute statistics.
It would have been funny if you used AI to generate that slide and it was actually 91.
It could be.
My answer is real world based. Everybody keeps talking about the inspections. They're not there yet. It's not there. The one use case that me and him know about, but that maybe he has more use cases than I know of. It was a very well thought out project. The inputs, as you were saying earlier, were very well thought out. The outputs are there. The people buying the things off the shelves and it's saying, oh yeah, it's gonna fix all your problems. It's an AI camera. It's gonna take it all. No, they do not work. They have a very limited number of data inputs that you can give to them, say like 100, and that is not enough information. Lighting changes in your room, as has happened here recently, and they're garbage.
Yeah.
This big paperweight that multi-thousands of dollars that you have to go back and tune again, and
That's a very good story. You have to go back and do rework, right?
again,
Yeah.
and again,
And again and again. It's the cycle of death.
We got 2 cameras sitting side by side, and the lights changed above them. One was a laser that was programmed, and no AI, just a very good spec. This is a laser. Here's a camera sitting right next to it with AI. Lights changed. That one went bad. This one stayed good. We had to reprogram everything. Hours and hours, days and days of reprogramming.
That is an incredible story right here. That ties back into our 80% failure rate. So what is the problem that we're going to discover is a lot of times when leaders see that it's failed on the promise that was given to them is maybe the AI is not good. So we need better AI. We need to get a better vendor who's gonna come in and do it better. They're gonna deploy it a little bit better. But when we look into what's happening, is many failures trace back to how it was managed to begin with. The technology is not itself the problem, but it's an approach problem. And what we mean by failure in this case is it doesn't always blow up. Like in this case, it was a very apparent blow up and it created a lot of rework. But sometimes it means the project just never justifies the investment. Sometimes it's just overkill. Sometimes we were promised massive results, however it just under-delivers and it's just a flop. And so the 8 reasons AI projects fail is the first row we have unclear problem definitions and process chaos amplification. What do we mean by this? If we do not define what we want to get out of the AI implementation, it is very difficult for that AI to solve the right problems because we don't know what it is. So what happens a lot of times is we get really excited about the promise of AI, and then we go and develop it, and then we try to find a problem to fit it to, which is technology-led thinking. Is okay, I have this tool now, I want a chatbot that's trained on all my organizational documents. Now I'm gonna go find the problem to solve it with. And there's a mismatch of need versus cause. And so what we then realize is without unclear business problem definitions and technology-first led thinking, what happens is we will realize that automating the bad workflows that we did not document is going to just get amplified. So the problems that were happening, maybe the lighting changed and we brought a better AI, it happens again, or it happens differently, or it happens faster. Because AI is very good at amplifying the process that it enters, because it is a form of technology too. And any technology put on top of a bad workflow will just amplify it. And this is going to be something that we're going to refer to again and again throughout this presentation. The second point that we're going to look at is data blindness. We just had a discussion about what is the problem, why is it so hard to trust the output of these AI systems at times, right? He brought up a very good point of, you know, I've noticed it's not very good, and we've got another case here, it's not very good. And the problem is a lot of times the data blindness, we never took the time to clean the data, understand what kind of data do we have. Is the data good quality? We just, oh, here's a bunch of data, we give it to the programmers, build me something. And the poor programmers are going to say, okay, I guess we're going to deploy it based on limited data. And so it's not going to be very good. The last one is no feasibility gate. There's no clear framework to follow. You just give it to developers and hope for the best. And this is against industry best practice project management, right? And there's no missing process ownership. Who owns the project is usually just the devs. And there's no clear process level ownership. So we're going to see how we can fix the failure rate. So the process first foundation is a core solution to this. And what is a process first foundation? It's really a philosophy, is that technology is a tool, AI is a tool, and the operation must come first. And this is a philosophy that we hold very dearly, and we teach it to everyone that works at Illuminate Strategies. Is we don't think technology first. When we face a problem, we say, understand the process level details. What is happening for that person who's doing the work on the factory level? Why is it that the sensor is changing? They will tell you the light is changing and I have to reprogram it, right? You have to understand the realities of the people that do the work. And so this is a quote from Bill Gates. And he says, the first rule of any technology used in business is that automation applied to an efficient operation will magnify that efficiency. The second is that automation applied to an inefficient operation will magnify the inefficiency. What do we mean by this? What do you think he means by that?
You're still getting the same output as you were anticipating, it's just that you're, like you said, like if the operation's now sped up, but you're producing a bad part, you're just producing bad parts faster.
Yes.
That's all it is.
So AI becomes an amplifier, right? It amplifies the system that it enters. And so
on your last slide,
yeah.
One of the most interesting things for me, because this is something that we see all the time and struggle with, Bill Gates said this like 30 years ago, and we're still tripping over it.
Yes. It's still prevalent
That's
today.
crazy, 30 years ago.
And so this brings us to the process first philosophy. And what is it? It's a 3-step way of thinking about problems as a whole. So the first is understand the operation. Number 2 is to optimize before automating anything. And number 3 is to amplify with technology only after we understood our processes, what kind of data is entering, what kind of data is coming out, who are the people that are doing the actual work at a line level. So we want to be very clear, super detailed understanding. Then only we can go and find ways to make it better. So when technology enters it, it is actually going to make a change. And so this also brings us to the business process reengineering model. And so that philosophy, this is how you implement it, is you define what's actually happening today. That's our current state of understanding. Once we have a clear understanding, we understand what are the opportunities for me to go and fix some of the problems that are occurring by talking to the people perhaps, by understanding the process. Surfacing, loops, delays, non-value adding work. Developing a future state, what does the dream world look like for us? If we didn't have these problems, what could that look like? And then understanding how do we close that gap? And that's when the benefit realization comes. Once we do that, we bring in technology to amplify what's already made good using our minds before we bring in AI. So this brings us to the process maturity curve. What is the process maturity curve? It allows us to understand levels in an organization. Before we get to that, we can take a look at what immature processes will give artificial intelligence if we decide to bring them into our organization. It will give us inconsistent data, which is unusable for training. It will give us unclear ownership. We don't know who's doing what. We don't know who to go to define those. There is hidden rework, just like you said. You have to go back and change the programming because that specification was not listed because we didn't talk to the person that knows that line best. Unmeasured steps. We have no baseline data for improvement. How do we know this AI is actually delivering on what it promised us? Tribal knowledge. We know how things are done. How do you know? We've done it this way for 40 years. When someone is coming into our organization, we'll teach them by verbal knowledge exchange. Fragmented workflows. Nothing to automate reliably. When we have a mature process, this flips around. Structured, reliable data becomes ready to define ownership, clean workflows, measured performance, documented knowledge, consistent processes. So process maturity becomes the prerequisite for everything else. And so this leads us to a 5-step framework. We have stage 1, which is an organization is fragmented. Stage 2 is forming. Stage 3 is structured. Stage 4 is integrated. And stage 5, it becomes transformative. Stages 3 to 5 are best to bring in AI. If you're at least not a 4 or 5, you won't get the best benefits. Stage 3 is okay, but it's not mature enough yet. So we're going to go through an assessment here to understand where we are, or a hypothetical situation. But stage 4 and 5 really become the best place. So stage 1, we have no standardized workflows or standard operating procedures. We don't know how work is being done. Forming, we have SOPs, but the team varies. Goals are defined, but outcomes are not measured. Structured, we have KPIs that are tracking. We have kind of data starting to form. Stage 4 and 5 is really when the organization is becoming a Lean Six Sigma culture. We're taking Kaizen approaches. We're doing projects. We want to get better to move up the chain. And so I'm going to hand out these self-assessment, which you can complete on your own time, just to see the questions that we should be asking ourselves. I might run out of copies.
Said if you do, I might be able to come through some.
Did everyone get a copy? So I would encourage you to go through these questions afterwards, after the session, and in the interest of time. And as you go through it, we have 6 dimensions of maturity assessment. And for the students, you can feel free to think of an organization and then rank it and see what kind of questions are going to allow you to see where an organization falls. And then this will allow you to see where you are on the curve. But again, I want to emphasize, if an organization doesn't have the base mindset and the culture to say we're going to remove our 8 wastes, and identify opportunities to improve, it's going to be very difficult to realize the benefits. So we're going to ask ourselves Socratic questions before we bring in AI. What are the 5 stages that we are on today? Where on the maturity curve are we? Does our organization have reliable, owned, structured data? Because data is going to form the reliability of what we're doing. Could you name the person who owns the most important process and describe what they own? And for a readiness question, what single thing would most improve the process maturity before bringing in any AI initiatives? And then understanding where our data falls is very important. At the top, we have wisdom. This is human judgment level, something that we talked about. AI is not there. This is very good for engaging our subject matter experts in an organization. Understanding is reasoning about the why. AI advancing, but it's still not there. Any data which meets the knowledge baseline, which includes patterns and predictions, is where AI shines. If we have data that is simply raw facts, it's better to just get a database rather than bring in an AI project. It's overkill. If you need information at that stage, analytics and reporting tools like Power BI are better tools. Not necessarily AI yet. When we need knowledge and we want patterns and predictions, AI is incredible. And so I want to quickly run over the CPM AI wheel. We're not going to cover 4, 5, and 6 because this is where we hand it off to the developers. Phase 1 is what we just discussed today in detail. So you now have a good understanding for the model it takes to make AI shine. And that is good business understanding. It's process level detailed understanding of what kind of data we have, what kind of operations we have. Go in and fixing that. And then from that, we will get data understanding. Inventory, assess, plan for data needed to power the AI solution. Phase 3 is data preparation. Once we've collected and understood all the data that is available to us, we start to prepare it, and then we hand it over to our developers and have very clear expectations for what we want from that project. This is a loop. And one thing that we need to keep in mind is phase 1 to phase 3 is 80% of a project time being spent. So if you're deploying an AI project, 80% of your time is really understanding your requirements, being very clear about what you want. Data, data, data. So process first, data second, AI comes third. And phase 4 to 5 is then we pilot it, very small. Because if we go full in and we deploy it and then we realize it never worked, it's changing based on light conditions, it failed to deliver. So this is industry best practice based on Project Management Institute's CPM AI framework. 6 phases of AI project success. It's iterative, data-centric methodology, which helps us loop over and over. Feasibility gates are very important as part of that methodology. Business feasibility, data feasibility, and implementation. So 3 major phases there. For business feasibility, we need to ask ourselves, is there a clear, well-defined problem that we're trying to solve? Is the organization willing to invest in change? Is sufficient return on investment measurable? So that when we talk to our developers, we can say, yes, you met the objective. If not, go back, define the business requirements, and try it again. Data feasibility, does the data measure what we actually care about? Is there enough data and is it accessible? Is data quality sufficient for model training? When we go to implement it, do we have the required technical skills? Can we execute within a realistic timeline? Can the model operate in the target environment? In each of those 6 areas that we just covered, we need to ask ourselves, did we meet everything here? Did we define the problem, clarify goals, determine whether AI is the right solution? If no, we go back and we do it again until we meet that toll gate, then only we go to the next phase. Did we inventory, assess, and plan the data needed to power AI? Yes or no? If yes, we move to data preparation, which is cleaning, labeling, and pipelining the data, which then goes to deployment, development. And you can start to think, if you were leading an AI project, what is one quality, reliability, or lean challenge you face today in your place? If you're a student, what is one thing that you wish SIU did better? You know, can you see opportunity for SIU to become more mature in their processes and the way that we do things? Maybe it's our hiring of staff. Maybe it's how we onboard students. What data already exists around that problem? Identify which of the 7 AI patterns will we need best, and what would make it the right match? And then what will we need to be true about the processes before we can bring the AI in? And those questions can be found in the questionnaire that you received. Lastly, what is the path to AI readiness? What can we do today to prepare ourselves? Assessing process maturity is number 1. See where your organization is. Number 2, understand where we fall in the maturity curve. Number 3, bring in a data team to really understand ownership and quality standards of what we expect. Understanding the business requirements, understand the future state where we want to be, and then work ourselves backwards. And then pilot small. So the model here is think big, just like OpenAI's vision statement. We think really big and vague, but that's the dream. And we find ways of how to close the gap. So think big, start small, and iterate very often. And then we need to build process literacy, data literacy, AI literacy, and project discipline if we're going to be successful and not become part of the 80% failure rate of AI projects. So these are a couple of things that we can start to build over the next couple of years as AI becomes more important. And to close it off, this is really a formula that we can take away from this session today. Process maturity, plus the CPM AI discipline of having a framework that is industry best practice, combining that with the right AI pattern of the 7 tools that are going to fix the problem that we're trying to solve, would give us AI projects that succeed. And to leave it off with you is think process first, data second, and AI and technology comes third. Thank you very much for attending today's session. It was awesome to talk with you and learn about how you're using it. I am on LinkedIn. If any of you would like to connect, I would love to continue the conversation and connect with you. Thank you all.
Right.